There we go. Okay. So for starters, our first topic we'll begin with is the discussion of when to use functional programming. So that was a question that Yuri brought up, and I'd like to hear from you, Yuri, a little bit more about what you mean by that question. What brought that to your mind?
Right. So when I talk about how I'm doing Clojure and Clojure script, often the recruiter asks, why do you use functional programming? And I try to answer, and I will say something like, because it's a data-driven and it's clean, and Clojure uses a lot of library from Java and JavaScript. And I tried to say something, but I don't think I fully understand it, so I want to discuss today and really.
That's great. Thank you for the context there. Yeah. So I got thinking a little bit about why functional programming, and in my relations, I don't deal with recruiters as directly, although I did deal with one yesterday who I'm trying to relate to you guys because he has a big thing coming up, and I thought, hey, some of you might be interested in that. So anyway, though, the concept there of why functional programming in my circles is often why Clojure, because in the research community, they'll say, if you're doing functional programming, you should be doing Haskell or maybe Scala. Some people think is more popular. And then there's the vague people I've met over the years who think that Python is functional programming. So there's a lot of take on that. And then, of course, in JavaScript, you can do functional programming because it's very ambiguous that way. You can do it either way. So in that one, it's more why use Clojure. But I think that there's some relation here. And I think that one of the things I wanted to mention when I thought about your question was what you mentioned already. So one is the data orientation. Mm-hmm. So in not all functional languages are data oriented. However, I think you probably really benefit from being functional if you are data oriented. I'm not even sure if it's possible to be properly data oriented if you're not doing functional programming. And by that, I mean, you're using data to control the flow of your program, and you're modeling most of your program's interactions by the transmission of data that you are transforming or that you're passing through or that you're reading to decide what to do next, as opposed to objects or in-memory decision trees that are based on extra data. So the data orientation is a big one, and Clojure is good at that. So Dan was telling me a minute ago that that's actually part of the reason that he mentioned that some people wanted to move from Elixir to, which by the way is known as a very good functional web system. So Elixir is well respected. They mentioned that one of the reasons that they thought about Clojure was because it's good with data, and that's very true. Did you want to say any more about that, the data side of things, Dan?
One thing I guess occurred to me as you were talking was like a lot of, like, if you think of like object-oriented languages, like an object often, it bundles together both data and functionality. Like an object will have methods on it, and whereas functional programming very much like separates those two. It sort of, so if you think of almost all computation like as data, it's some mixture of data and computation. Then functional programming kind of like says, okay, this part we'll just pull out the computation over here, and then well, what's left? Like just data, right? And I don't know. It was interesting turning over that idea in my head. Like, oh yeah, like what would data-oriented programming look like that wasn't functional programming? And frankly, I couldn't really imagine it. Maybe there's some weird way, but the one thing I do think it was another good thing I think that you highlighted, that a lot of people, when you say functional programming, maybe like certainly in my head, the first thing that comes to mind was Clojure because it was my first introduction to that. But there is a large world that thinks of other languages like Haskell or Scala, or and so I guess for Yuri, it would help to keep in mind that not every I kind of put those two together in my head, but not everyone else does, and right. I think I'm in the minority.
Right.
Yeah, those are my thoughts for now. Yeah.
All right, I had a couple other items that tie in here. One thing just to close out the data orientation, I was reminded of an issue I've had ongoing for a couple of weeks now. So Madeline, this is a project I've been working on with Kelly, where it's a WordPress thing, and we're attempting just basically PHP is not data oriented, and traversing data in PHP is a pain. In this particular problem we've had, we want to fill some buckets with data and then go over and use that data on some of the things. So this is related to kind of related to what Madeline's doing in Clojure script. It's going to be much nicer there. The issue we've had several times has been, sometimes our bucket gets full of arrays, and there's a certain way of going over arrays in PHP. And sometimes it gets full of WordPress objects, which apparently you traverse in a completely different way that we haven't figured out yet. So it's a mess. And if it was properly data oriented, that wouldn't happen. So I keep on wishing I had threading macros like in Clojure, because it's so easy to just move through data, and especially with the REPL, because with a functional system, you're doing composition, especially the way Lisps do it with the REPL, then you're just adding things as you go. And so you can build your process as you go. Whereas the process with the PHP and the WordPress is we make a change, we put a bunch of print statements that are going to spit data to the screen, and then we refresh our browser and see if it's working. And it's a mess. It's not fun. So the data orientation is a big one. The next one I mentioned is testing. So this is, testing in software is good everywhere. It's important everywhere, I should say. In functional programming, it is much nicer because you have small functions, and the whole purpose of a pure function, to use a term that was invented, I think, by Haskell, the idea of a pure function is a function whose action is purely without side effects. So when you have a pure function, you put stuff in and you get stuff out, and that's all that happens. The stuff you get, nothing else is changing in your system, just those two things. So when you're doing testing that way, it is so much easier, so much nicer, because your testing suite just tests, is my function working? Is it putting out the right thing when I put in the thing I want? That's all. I don't have to say, I have to reset a counter now because every time you run this function, it builds this other thing somewhere else and blah, blah, blah. You don't have to do that because this is functional stuff. So testing is a big one. Testing is much easier. And the last thing that came to my mind was understandability. So sometimes this is talked about as readability or other things of like knowing your code, because when you're a programmer, you have to run the program in your mind. That's the job. That's part of what you do. And so things that make that harder are things that are complex, things that have changes all over the place, things that are mutating. So you have to say, okay, well, I had a car and now I added another wheel and I changed its color, and whatever you've done to that car, I've spent some amount of gas. And so suddenly you have to track all the stuff in your head and you're computing everything mentally. And that's a problem with some object-oriented stuff. They have to fight against that problem. Now that's not, I don't mean to slander object-oriented, because that can be a very useful paradigm. But for understanding how the system works, functional programming, especially as the system gets bigger, is just easier. It's better for comprehension. Was anybody want to add anything else on this topic?
Now I thought about REPL is one of the big things for Clojure too. Like I can run the line. I can't do that with other like Python projects that I'm working.
Yeah. The REPL is a big deal. And sometimes I've thought, I've met people who are like, well, I've got a Python prompt. I can fire up my browser and I've got a console right there for running my JavaScript. That's the same thing, right? Yeah. It's actually not. So REPL is different because the REPL is the actual system itself. You're interacting with the actual running program. And so not only do you have, so the Python limitation is that the command prompt can't do everything that the Python can do. You're in a subset. And with running things in the browser, you don't have a clear distinction of what's the system and what's the JavaScript you're running in the prompt. And so certain things, you're in a really mutable environment, and so you have a lot of things changing. I have to think about that one a little more, but the REPL itself is really a terrific tool for interacting. And so some people even have a REPL going on the live system so that they can log in and make changes. A long-standing joke that we have with Dan is put a REPL in it, because that's like an answer to a lot of things. We'll just put a REPL in it, and it's going to make us able to more quickly make changes. So
does the REPL comes with Clojure, or that comes?
So yeah, so the REPL comes with so Clojure itself, because of the way it is, it has a REPL because the read, evaluate, print loop is literally how it's reading the code files.
Right.
So there's always a REPL, but you need to have an editor that knows how to connect and start up its own REPL process to really make the most of that. There are a lot of such editors, but like Notepad++ is not one of them. But you have a lot of other so Madeline uses VS Code. I've had people use Vim. I've had people use Atom and use a number of IntelliJ, Cursive. There are a lot of options. Of course, I use Emacs. There are good options for having that REPL, but the most important thing is to be able to interact with the code.
Okay, I didn't know that you can do REPL with VS Code.
Yeah. Madeline has that going, and it's pretty. So Calva is the VS Code plugin for that.
Mm-hmm.
And whatever my feelings about Microsoft might be, Calva is a good piece of software.
Okay.
All right. Those are the three things that I had in mind. Anything anybody else wants to mention about functional programming or questions about functional programming? We talked about.
I just wanted to throw in that there's a different way to code when you're doing functional versus object oriented, and I felt that as I was learning Clojure, because I started object oriented and I still do dominantly object oriented programming, but as I've learned things from Clojure, I've been able to I haven't been able to take everything over, because not all of it translates back into object oriented world, but I think it has opened my eyes to a lot of other programming concepts that are just universal, like relying on abstractions and, reusing your code. I think I really like functional programming and like the whole passing functions around. And one of my favorite things, this is what always kills me, is whenever I work with a lot of kids and tutor them how to code. And one of the things we do is we've made a calculator app before. And, when we make a function for addition, subtraction, division, all that jazz, all of them look almost exactly the same. And I'm just man, if we could just pass the plus sign function into here, and this would be so much better. I could just pass what symbol I wanted to use, I could in Clojure, that would be so much better. So there's definitely times where I'm thinking that, where I'm wow, if I could just pass the math functions the way that it works in Clojure, it would be so much better for code reusability. So yeah, there's definitely a lot of pros to being able to just loosely pass functions around the way you can in Clojure, whereas you can't do that as much in Java or C.
Yeah, Java, you have to pass interfaces because you're passing methods, not functions, right?
Right.
And then in Python, you can actually do it. So Python lets you pass functions kind of. With C, you're always dealing with pointers, and that's obnoxious. With JavaScript, you can do it. With PHP, you cannot do it. You cannot pass functions. And so it's, at least in the old PHP, you probably can in the new one, because that's one of the things in functional programming that is becoming mainstream. So first-class functions, meaning functions can be args. That's one of the mainline things that's coming these days. That's always been one of the hallmarks of functional programming, but these days everyone is realizing, hey, we need this. The other one is lambdas, so inline functions. There's a lot of stuff that I even forget is functional programming, but because I've been in so long since I've done anything else. But that was one of the big stings when I step out is, whoa, you're telling me that you don't have lambdas, or else they're really awkward. So
yeah, that's another thing that's really changed with my programming since starting Clojure is lambdas. Definitely optimize lambdas a lot more than I used to.
When I first learned Clojure, I was working for this small company in Orem, and they were doing everything in VB.net, I think it was, which nobody uses that anymore. But so I was just even learning the idea of chaining functions together. So my code started looking very interesting. Think a lot of nested parentheses in an editor that doesn't handle that very well. So anyway.
I was working with somebody the other day, and that one was in JavaScript, I think. It wasn't even Clojure, but he was writing his code into a text box on a browser, and he was telling me how he didn't want to write it in an actual editor because he felt like that'd be cheating. Like he was in a code boot camp thing, and he felt like it'd be cheating if he used an actual editor and copy pasted it in. And I tried to tell him, no, that's the way you do it. Like nobody writes code into an editor, into a text box. So that was a discussion. Yeah, editors help a lot. Okay, is there anything else on the topic of functional programming for your question, Yuri, that you'd like us to think about?
I think it was a good discussion.
Thank you very much. Okay, so I am done with that one. And then we're moving on to HoneySQL. So we had a question on this one. And so Madeline, you're working in full Clojure script, and so this isn't directly applicable to you. But the concept, the gist of what Honey is, so Honey is a system that converts data structures in proper Clojure fashion into SQL statements. And so like a lot of Clojure things, that means that you do need to know the underlying system a bit. So you need to know what SQL you're writing before you can convert Clojure into that very well. So we'll talk about that a little bit. Honey is made by the excellent Sean Corfield, who I really love his work. And some of you may have even seen the Clojure Provo meetup he gave before he gave another meetup with the same presentation on his REPL development, I believe. But he's now made another version of Honey that we haven't moved to in our project yet, but that's there's honey.next, I believe it's called, and it has a number of nice changes, including, so he's really good about like optimization changes. So he's not like one of these open source guys who branches a project and makes his own little version, and maybe it kind of works sometimes or not. He's very professional, and so HoneySQL, when he took it over, he didn't first come up with it, but he took it over from the fellow who's leaving it. And it's been a good thing. He does great work. His code is quality. So if you want to see what good Clojure code can look like as far as readability, check out some of his repos, because they tend to be well written and well documented. So, okay. With that, let's move a little bit here, and I will share my screen and what we're talking about with HoneySQL. Now, this is a question that came out from Easton. So as we go, Easton, if there is a particular direction of things you're wondering about, you mentioned to me joins, for instance, but there could be other things as well. So we'll look at some of those in particular for how to make those work in HoneySQL. So let me share the window I've got here. All right. So first off, we have several topics I've got listed here. All right. So we'll start by looking at the kind of stuff that comes out. So we're going to go through the process of writing things. I mentioned already that you need to have a feeling for the SQL you're trying to get, and that helps. And so once you have, if you have that in mind, which admittedly I sometimes don't. So there are times where my SQL knowledge is not enough yet, and I'm learning things sometimes from you guys that I've not known in SQL. So, but assuming you know what you want, let's work our way there. All right, so I've got a function from one of our projects. This is actually hum help, Easton, so it may be familiar to you. But this is a function that is running our Honey data structure into Honey, and it's going to connect, work it against the database and give us a result. All right, so the first question, you'll notice here, first off, we're using a thread. So maybe Madeline, this might not be syntax you've used a lot yet. It's very useful. So the way the single thread, meaning there's only one greater than sign here instead of two. This is called left threading. It means that we're going to start with some data. In this case, we got a map right here. This whole map, all these lines, is one object in data. So we got a data map here. And it's going to pass it through, and it's going to be the first arg that goes into the function listed next, SQL/format. And whatever comes out of that function when it's given that arg is going to be the first arg given to this function. And so on, finally to vec. Okay, So this is going to build as it goes here. So I'm reading, in this case, I'm reading some code that's been written by somebody else, and we are going to figure out how this works.
So if you had arguments in those other functions, where would they go? Or would you have to like create a partial or something, or a lambda?
That's a very good question. So there are a couple of ways to approach that. So this is a question about threading macro, and it's very welcome. So one thing is the difference between the left threading macro and the right threading macro, meaning the difference between this and no, that's not the one. This. Okay. The difference is when I do the right threading macro with these two arrow symbols here, then it's going to stick the arg in as the last argument to the function rather than the first. Now that doesn't completely answer Easton's question because that only handles two cases. Now in the case, a lot of the time, this is why nobody says you how many params you're supposed to use in Clojure, but you try idiomatically, you keep it as few as possible. My rule of thumb is you want 3 or fewer, and if you're going to need more than 3, you better stick them in a map or a collection, because probably a map. So you should use a map instead of sequential path map, because sequential args break. They're just not very good programming. And that's one of the big things when I see old code bases. There are a couple giveaways. There are magic numbers, and there are too many sequential args. There's nothing like dealing with an old function in C or something that takes 7 args, and you have to get those in the right order, and it's just a nightmare. So, okay, anyway, what happens, though, if you do need some more args? So if we only take one arg, our threading arrow, having a left threading or right threading is the same thing for a single arg function, because it doesn't matter if it's first or last, it's the same thing. If it takes multiple args, which there are certain types of functions, so especially higher order functions like map and filter, things that work on collections, where you have to think about this because your first arg is going to be the function you're doing on it, and the second arg is going to be the actual collection, or vice versa, usually vice versa. Then you want to be able to include 2, and there's several ways to do that. So one is to think about the right arg number, the right arrow, but another one is to wrap these in parentheses. So suppose that, no, that's the wrong key. Suppose that we do this guy. So DBR, suppose it takes multiple args here, which I don't think it does, but if it did, when you wrap it in parentheses, the threading arrow is going to give it whichever you say, but it's going to also take the functions you say. So this is left threading, so I'm going to say arg2, because the previous things need to come in, remember, as the first arg, because it's left threading. If this were right threading, then this would be like arg1, because the thing that comes in is going to come in as the last thing. So you can do it this way, and sometimes you'll see people who have an old habit of wrapping. If you read Clojure code, they'll wrap every step of their threading macro in parentheses, even if there's no args.
I am one of these people.
Yeah, it's not necessary. It doesn't do any different. So, but if you have args, it matters. You can do it that way. So that's one way to. If you still have your arg coming in as the first or last, then here's how you can fill in the middle ones. Another thing that I often do that I like for the readability of it is, let's see here. I would say, usually when I write my functions, you've probably all seen this by now. I start with the let. And so I'll put some functions in here. And this is higher order programming, but let's say select even, make it a function, and this is going to be an anonymous function, right? So I'm sticking a function into a variable, and then I'll have blah filter, whatever. And I put in the arg. So this is an anonymous variable. I usually prefer to do actually fn here because it's just a little easy. Again, this is about readability. And so FN, you've got your, you can actually give it a name, which helps if you're in a debugger. So I can call it, again, whatever I want here, doesn't matter. Or you can just skip the name altogether. So it's just when you're getting a stack trace, the name will show up in there if you have a name. Otherwise, you get some function number, blah, 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 memory, address, stuff. That's not helpful. But okay. That's a bad name because it's too big, but it is explaining the purpose here. So and it tells me that I have put, oops, sorry about that. Let me switch back here. It tells me that I have pushed that in the wrong order. That is probably still the wrong order, but you get the gist of it here, right? So, and then I would say, okay, now I've got a function up there. I'm going to make sure that this wraps the entire next thing so that it's within the scope of the let. And I can say something like results so far. No, I called it select even, like this. So this is a way of being very verbal, making it so it's easy to read, right? So here I can, if I have args I care about, I can stick them in that function up there. So that's the easiest way to deal with args in your threading. And I like this because it's very readable. I can give it a good name and I can just stick it right in line. And so I'm basically making a function with args into a single argument function that I can just stick in the thread. Does that make sense, Easton?
Yeah, so this is preferable over the first thing.
Yeah, I think so. Now it's possible that you're writing very small function cases, and so you feel like you don't need to rename a whole thing because maybe filter, well, that's usually a bigger one, but maybe even question mark is, there's already a function and its name is already what I need, and so it'd be redundant to add an extra named thing wrapping a thing that's already telling me what it is. So in that case, I would do what Dan does and just stick it in the parens. But if it's anything more elaborate, then using the let form, or there's also a thing called let fn. I think it's simple to use let because then you can mix functions with data and you don't have to make a new statement. But anyway, I think that's easier in this case so you can have readable code. All right. So let's zoom backward. All right, so here we are with our function here. It takes no args, and it's going to do something to our database. All right, so we're assuming that maybe we're reading somebody else's code, but you can see how this will adjust to if we were to write our own SQL. So one of the things that's very useful about doing it this way, so the threading args, and have even the syntax this way, is watch how easy it is for us to investigate things bit by bit here. So first off, we start off with a map. And we know that Honey is going to take that map and convert it into SQL somehow. And so we assume that all of these args, select, group by, left join, order by, from, these are all meaningful parts that they're correct. So we assume those are correct because somebody else wrote this and it's been working. But in any case, we're passing those in. And then we have a namespace. This is the honey/SQL namespace, or honey.core/SQL. So it has a format thing that converts your data structure into an SQL string that can be handed to an SQL adapter and run on the database. All right. So the first thing to do here about the debug is when I have a thread like this, I can comment things out and see what it's doing so far. So in this way, I've said, okay, I'm going to do SQL format, and I want to see what comes out of just that. Before, I'm not hitting the database. I'm just saying, what string do I get? And so again, this ties into what Yuri has mentioned with functional programming, what we talked about a minute ago. So the ability I have in the REPL, and I don't have a REPL prompt open here because the most important part of the REPL is that my code is my REPL. So if I want to do this instantaneously, I'm going to go one step back and put an enter here so that we have a difference, because otherwise I'm just deafening it again, and that's not what I want. I want to actually run the action, which is possible because there are no args in here, so I don't have to do any funny business to get this to go first. So let's just run this guy, and I've got a syntax error that I didn't have a minute ago. All right. Does anybody see why I've got a syntax error there? It's annoying as I did do this one beforehand, so let's try regular comments instead. This should give us just the map, which it is still
It doesn't
having.
have anything to thread it through. That's why it's complaining.
All right, the map itself is having issues. Let me revert the buffer here because it was working a moment ago. Oh. I don't know what happened to my REPL, but it seems to have gone. So we'll start it up again. That would be the thing because I don't have a REPL going, so I can't run anything useful. Okay, so what I'm going to show you here, so the first step into doing the honey stuff. So you assume that you have an idea how the SQL should be. So there's my REPL. I'm going to do start, which is going to connect me to the database. Okay. And then I don't need that prompt anymore. Well, of course it's already in use. I already had a REPL somewhere. Okay. All right. Here we go, though. I may not be able to get the database, but you can tell here. So I ended with SQL format. So it's giving me the output of what happens when Honey parses that data structure. It comes up with this data point here. So if you know what you're looking for, you can read it right here. If you need to persist, you can use your editor to do that instead. So in Emacs, that's Control-C, Control-P. And here we go. Here is the string, and you can tell that the way that the adapters expect it expects it to be in a vector. But we have a string coming through here, and this is the SQL statement that we're going to get. So when you're debugging these things, you think, is this the one I want? And further, does this even work? So the next thing to do then is, let's try that. I think I got it. I have a prompt open here. So this is not the project. This is just a prompt into my database. So if you use Emacs, you can do this in Emacs. If you want to do it elsewhere, you can do it however you want through your shell prompt, whatever. I've already logged into the database. I've already connected to my local version of this database, the same one the program is connected to. So let's go ahead and try this out. Here's the string that just came through. I think the difference when I'm at a prompt is I need to make sure I include a semicolon at the end. But let's see if it does anything. It did. Okay, so it works. We didn't get an SQL error here, and this is a great way to check things. So there we go. So there you can validate that this function with SQL format, it comes through. And so in return, we can say, okay, if I turn this back in, now db/dbr, that's one of our functions. db is our db.core namespace, and dbr is our read function that passes through the Java adapter into the Postgres, and Postgres is going to give us back the results. And then vec here, it was because he wants it to be in a vector, because the other functions expect that or something. Maybe it comes in as a list. So let's see if the connection is good enough. If the database connection worked, I should be able to run this. There we go. So now we have a Clojure thing. So when it goes through the Clojure, we've got it. Now this is, I think, the first most important part of writing things and debugging things with Honey. So by the way, so Sean Corfield himself and the Honey documentation recommends their use of helpers. They have a bunch of helpers to help you build the data structures where you'd say something like, oh, instead of, should I put a left join on there? I have a helper just called join. And I just call it in a thread macro like this, and it adds that for me. That's actually the one thing I really disagree with Sean on is that one point, because I like to be data driven here. And I like to know what data I'm working with. Now, there are exceptions when the data structure gets so complicated that it really helps to have some helpers to deal with it, because maybe there's a lot of nesting or something. In this case, the helpers might help you, so you need to know less SQL. I don't think that's a good thing, though. I think that we can afford to learn some SQL. So I recommend just doing it with the data, and so that's what we do in our code bases. Just use the data structure itself, and then use this system, this format here to say, okay, I can examine the SQL that gets generated. Remember that it's not doing any checking. It says your data structure made this string. I don't know if that's a good string. Maybe SQL hates that string, but it made that string. And then I can say, okay, now let's actually try it on the database, and then do whatever we need to the results. Okay. So one of the any questions about that so far, about using Honey and building these up? Okay, then let's look at this a little bit more piece by piece, because there are some cool things in Honey, especially as you come to know more about databases, that you can find out that databases like Postgres and other ones have different features. But Postgres has a number of functions that can be useful, and they're using some of them here. So they're using the count function twice, in fact. They say, okay, we can kind of guess what this is doing by reading it. It's got weird syntax because everything's a keyword in original Honey. I think that there might also be a way to use just a string, which might be, if you know your SQL, that might be simpler. But you can kind of guess what this is going to be here. We've got, there's going to be a minus, and remember we're using Clojure, and so it looks like this is going to be RPN, reverse Polish notation. So in an actual SQL, you would write blah, 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 minus blah, blah, blah. And of course, in Clojure, you write minus the blahs. So, okay, we're going to subtract. We're going to start with our count of everything, count.star. If you use SQL, you know that one. Count.star is everything. Take away the count of the deleted clients and put active on here as part of the select. Now, I actually don't know what that does. I don't know why active is needed there. But you can see what that does, and then we can say, okay, if I evaluate that, just that, I get a native SQL call, which is going to be something given by Honey. So it's just a function call with those args. Nothing interesting there. It was what we expected. But of course, this being REPL driven and all, we can, let me narrow to just this thing. And because of the syntax, this is why I like these big maps to be on multiple lines. All right. And once again, let's just get our string back. All right, so now we have nothing but that select, that call thing. And then now we can say, what is that actually doing here? So this is the string that comes out of that. So we've got the 2 counts we expected. Oh, okay. So the active is not a keyword that is the active is not a function word that is being used. It's the alias. It's going to be called active in the column on the results. Just the naming. And then we have the department ID. And so you can see the syntax, the way that's working there with Honey. So typically when they are wrapped in vectors, then you have the action, and then it depends on how those vectors are treated. It depends on which type of statement it is in Honey. But here in select, you can say, okay, this vector is going to say, here's the actual code that's going to be called. And it's an SQL/call, so it's going to be read that way. And then the second one is going to be what we're going to call this item in the select. We're going to call it active. We could have called it dogs or whatever we want. Doesn't matter. And then we're also selecting department ID. And this is not a vector, which means we're just going to call it department ID. Nothing special here. Same thing with d.name. And why it knows D is later. So remember that because it's generating SQL and SQL operates not bottom up the way that Clojure does, it's a little bit different. So then we get a group by. That's pretty straightforward for what it's doing there. Then on left join, we still have, here's where the D comes from. Okay, so this is to Easton's question about joins originally. We're talking about joins. All right, so in SQL, so technically when you're usually writing like your strings, there may not be a distinction. At least it's okay if you just say join. And I think it's actually okay that way in Honey as well. But left join might be a different thing than just join. And so you want to specify left join here. This is not actually, we're not talking about how SQL works here, so we're sticking with the Clojure, but just take my word that the joins can be different. The way it works here in the Honey is you're going to say first thing is, what's the first thing I'm doing? And remember, this is a vector, which means that I think it has to be a vector either way. But if you give it a second arg, it's going to be an alias. This is the D, and this is the reason that we can have d.name up here. Because of this D right here, we're calling departments D. And we're joining on. So this is the equivalent in SQL. You have join blah, blah, blah as or join on, right? So the second arg in the join, the second vector in here, that was the first one. Second one here is saying what's the criterion for the join? When the department ID of the main thing we're dealing with, which is the it's clients. That's down below us. It's clients. So when the clients.department ID equals d.id, we're going to join those. And then we've got an order by here, which is pretty straightforward. And here's how I knew that was clients.department ID, because our main subject is going to be clients here. All right. And so given this, we can say, what do we get? There's the string we get out of this.
Does it always just go in the same order as it is in the map?
No.
So
Remember
Honey
that
like figures out which way it needs to go.
So yeah, you don't need to worry about order because in Clojure, by nature, by definition, maps are unordered. So if you've ever been confused about that, like, hey, I'm using maps and I create a little map here and I print it and it's the same order as what I created it in, well, there's technical reasons for that, but just know that maps are not guaranteed to be ordered at all.
Okay.
So in this case, the order does not matter because it's a map. The order can't matter. And so it has those things in the map, and we get our string out right here. And maybe we know enough. Well, actually, we just did the test. We just tried it in the actual SQL terminal, and SQL liked it. So we're going to assume that we're okay here. So again, REPL driven. We'll just uncomment our stuff. I actually don't still know what the vec is exactly for, so let's see. So now I evaluate. Yep, sure enough, I've got a list. So parentheses, I've got a list of stuff. And I don't know if the vec is necessary here. But I have to assume it might be because suppose they're trying to use numeric accessors later on. It could either be that they're going to actually use the fact that it's a vec, which is what I hope it is, or it could be that they were worried about this being a lazy sequence. Because when you do stuff on the front end and you get results, they are often lazy sequences and you have to stick them in a vector or something to get them to realize. Maybe you've hit those errors before on the front end. So maybe they were worried about that here, even though with SQL, that's not going to be a worry. But at least with the way Honey does it. I think Honey next actually does some lazy sequences, which is actually really cool because if you can have lazy results coming from your database, that's kind of a power when you're dealing with big databases and big result sets. But okay, so we've gone all the way through here. We've seen what happens. Now, where to point you for? Well, what keys do I put in this map? How do I know if it's join or join as or left join or whatever? The best thing is to either consult code bases or to go to the documentation. Like I mentioned, Sean's documentation is good. So if you need to see the data structures, like I said, he'll recommend that you use the macros to help you. But if you use them this way, then there's a lot of benefits beside that. So again, I recommend not using the macros, but just look for the data structures. Now, there's one more tool here. You saw how I fired up a REPL and not a REPL. I fired up a terminal and connected the database with that to see if the query was good. Now, Dan actually has a different way that he's done this, and he surprised me when he did this. I don't even know I called attention to it, but you actually will do that kind of terminal into the database from your Clojure. How do you do that?
If I'm remembering right, I think probably what I did was, I mean, if I wasn't leveraging DBR,
yeah,
I'm not sure how I would have done that actually without. Yeah, what I can't imagine is I might have had. I think I might have even left this in a code base somewhere, just a function to execute like a string query. Which I know is, I feel like maybe I was just calling DBR somewhere, but it might have been outside of the function that I was working on, if that makes sense.
You weren't using DBR actually. Let me see if I can see what I think it was. Because DBR itself, I think, is using what you used just to make sure that things were okay. Yeah, I think maybe you did something like this. You did.
Oh, maybe, yeah, probably JDBC query. Yeah.
Yeah, so again, JDBC, if you're not familiar, that's the Java database connector. And so JDBC is one of the big Java, very active implementations used by a lot of enterprises that had nothing to do with Clojure. The Clojure wrapper for JDBC means that you can hand out these Clojure maps and things. Or at least not exactly, but it means that you can give it strings. So in this case, JDBC/query, I tell it which database is actually querying, where the actual connection. So this is a limit to functional programming because this is an object here. So I have an object of the database, and then I pass it a string. S in this case is a string, and that is going to be the result here. So in answer to what we were saying earlier, suppose you wanted to do a different, you want to test things out directly, then actually I will. What was that?
What was I doing here? I remember talking about this.
All right, that was a bad idea because that's a huge data chunk.
You know what I think it was, Tori? I think I added in debugging lines into the actual query, functions. I think I had it printing some of the values in there. If that makes sense.
Okay, but I do remember you doing these direct things where you were typing strings of SQL directly and bypassing the data structures, bypassing Honey, which is kind of a cool way of doing your testing. Suppose you don't want to fire up an actual prompt to connect directly to the database. You say, hey, my program, my REPL is already connected, so why would I bother with that? You can do it this way. Just give yourself a query and just type your own SQL string right here and see if it works. So in this case, you're back to string wrangling, which hopefully nobody here loves because that's not good. But if you're trying to get your SQL figured out, you can do it that way. All right. Any other questions? We're about out of time here, but we've got time for last questions. If anyone wants to ask anything else about anything. Okay. All right. I think we covered Honey then. Easton, do we satisfy your question?
Yeah, that was great. I'll be able to use that stuff.
All right. I'll go ahead and figure out how to stop the recording. There we go.